We are covering one-way and two-way slabs, along with reinforcement development length for the FE civil exam. The first concept is distinguishing between a one-way and a two-way slab, which is a common conceptual question. A slab's classification depends on the ratio of its long side dimension to its short side dimension. If the long span divided by the short span is greater than 2, it behaves as a one-way slab. If that ratio is less than or equal to 2, it's a two-way slab. For a one-way slab, the structural action is similar to a wide, shallow beam spanning in the short direction. The main reinforcement is placed in this short direction to resist bending moments. For a two-way slab, the load is distributed in both directions to all 4 supporting beams or walls. The NCEES FE Reference Handbook mentions design methods for two-way slabs, like the direct design method, but for the FE exam, you primarily need to identify the slab type and understand the load distribution concept rather than perform a full design. A common exam trap involves a rectangular slab supported on all 4 sides. For instance, a slab measuring 12 feet by 30 feet has a side ratio of 2.5. Even with 4-sided support, because this ratio is greater than 2, it must be analyzed as a one-way slab with the load traveling in the 12-foot direction. Now let's transition to development length, denoted as LD. This is the minimum length of rebar embedment needed to ensure the bar can develop its full yield strength through bond with the concrete without pulling out. The formulas for development length are in the Civil Engineering section of the NCEES FE Reference Handbook. A critical factor in this calculation is the top bar effect. A top bar is a horizontal bar that has more than 12 inches of fresh concrete cast beneath it. For these bars, a modification factor of 1.3 is applied, increasing the required development length. This is a frequently tested detail. An exam question might give you all the parameters, bar size, concrete strength, and cover, and simply ask you to calculate LD, but it will specify it's a top bar, and missing that 1.3 multiplier is a common mistake. Closely related to development length is splice length. A lap splice is used to transfer stress between 2 overlapping bars. The required length for a tension lap splice is specified as either Class A or Class B. A Class A splice requires a length of 1.0 times the development length, while a Class B splice requires 1.3 times the development length. The exam problem will either state the required class or provide conditions, such as the percentage of bars being spliced at one location for which you can determine the correct class. To remember the slab classification, use this simple phrase, L over S greater than 2, it's one way for you. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.